Alright, welcome to Team 7's Edge Detection video. So, for our applications in engineering, we mainly looked at biomedical engineering, even though there's a lot of applications elsewhere. So in medicine, there's lots of imaging being used every day, whether it be CT scans, MRIs, ultrasounds, or X-rays. So the biomedical engineers are the ones who design these devices, and they need them to work and need the images to come out pretty clear so that the doctors and medical professionals can see what they want to look at. So the image processing pretty much needs to focus on the target. So like for ultrasounds, they really only care about the fetus or the baby, so they don't really care about the other soft tissues inside the womb. So they were going to target the fetus so that the doctors can see how the baby's developing and, see any movement and all of that stuff. So for our code, this is our functions file. So we just have different functions to get the grayscaled image, get the blurred image, do the Sobel transformation, and get the final thresholded image. And at the end of each step, we have statements printed to the console to let the user know that the images have been, or like how each step has been completed along the way. So the user knows that, the computer didn't crash. Yeah. So in our main file, we do some error checking right here, but other than that, we just run through each step from the functions file, and then we save each image afterwards. So I'm going to go ahead and run this and show some error detection. So it only allows a PNG image to be input. So if I put coins, it'll say this file must be a .png. If I put coins.jpg, it'll still say this must be a PNG. So I put coins.png, and it starts to run. Now coins.png, that is an RGBA image. So our approach to that is we essentially just ignored the A value and only focused on the RGB values. And we do that for just the grayscale step, but then after that we just work with the grayscaled image, so we don't really need to focus on that anymore. So the final image has been complete. You can see down here in the console the different messages that have been output. And there's our final image there in the plots, but they also show up in the same directory that the code is stored in. So for the coins image, here is the grayscaled version of the image, then the blurred image, the image after the Sobel transformation, and the final thresholded image for that. So I'm just going to go ahead and look at the Purdue Arch image now. This file is larger than the coins file, so it has more pixels, so it's going to take a little bit longer to iterate through each step of the process, just because it has more pixels, so it's going to take longer. And our code isn't the most efficient. There's a reason that professionals use like CV2 and SciPy, because the people who made those modules figured out how to make this a lot more efficient and a lot faster, but our methods work at the end of the day. They still get the same job done, even though it might take a little bit longer. So once again, the messages are being output here in real time when each step has been completed, just so the user stays up to date on the progress of the progression of the code. So you can see here in the plots that final image has been completed. There it is. It's also going to be here. So here is the grayscaled image for the Purdue Arch, the blurred image, the Sobel transformed image, and the final edge detected image. And that is all for our program. Thank you.